I should do that. Nah. During marching season, Miss Slim was always like,
It's hot outside, so what are your instruments going to be?
sharp.
Then pull out your tuning slides and get down for planks or something.
Well, the problem is, tuning isn't really a thing you can do when you're marching out on the field, and adjusting just when you think it's getting hotter outside isn't exactly accurate. So I was like, wouldn't it be nice if I could tune my trombone without having to get yelled at because I'm playing without permission? Hence, a service thermometer to get the temperature of my trombone, put that in my phone, and then adjusting my tuning slide based off of what the phone tells me is about right. The things I need for this experiment are a trombone, which I have, a tuner, which I have, a phone, which I have, a service thermometer, which I could just buy online, and brain cells, which I could not find. That's weird. Anyways, I'll just order that thermometer in. So, for you non-music people, here's basically how this tuner works. These marks tell you how far I am from being in tune. When I play, this arrow thing shows me where in that range I am. I can record data about my tuning based on what I see that arrow pointing to. Now that the thermometer has finally come in the mail, let me show you how this works. I just plug it into my phone and put something in front of it. That's it. $13 well spent. This was painful. The only data that I needed to code my project was the relationships between temperature and how far I had to pull out my tuning slide. To collect that data, I recorded the temperature of my mouthpiece, played a B flat, recorded how many cents sharp that note was, adjusted the tuning slide until the B flat was in tune, and measured how many millimeters I pulled out the tuning slide. Here behind me is a minute-long clip of me playing notes and collecting data. It's sped up by 60 times, so it's actually an hour-long clip. I played B flats for over an hour. The sad part is that I only got 50 entries. It's like a single entry per minute in 12 seconds. Anyways, this is that table of entries, temperature in Celsius, sun sharp, and tuning slide position in millimeters. With a little bit of magic called manual labor, because I'm a boomer and I don't know how to use Google Sheets, I sorted that list by temperature in ascending order. After that, I put the data into this sketchy online graph maker website and got this. Looks about right. The data on tuning accuracy is a little more off. The data is more scattered, but it still matches up with the original position data. The graph slope goes into the negative values for accuracy, which makes sense because positive means I'm going sharp and negative means I'm going flat. But then this means that this set of data is basically irrelevant for what I'm doing. But let's get back to this graph. This one shows that the tuning slide position goes up in a fairly consistent slope until it drops back down at 33.8 degrees Celsius and starts rising again. If I just assume that I had made some errors when I entered the data, I could just ignore that and get this line of best fit. If I were to consider that weird dip as corrected data, then the line of best fit would look more like this. I think that this first one is more accurate because very rarely is my instrument going to get that hot to experience that dip in tuning, even if it really is correct. But now that we have the data, we can move on to... Did I make a transition for this part? The coding part was really underwhelming. I took some pictures of my trombone's piping and cut out the background with my drawing app. And then for the bell and neck, a part that I didn't need to move, I split the image into two sections so that the inner slide wouldn't overlap and look weird. I put those images into the user interface, and now I have this. But then I was like, but you have to make the user interface match the screen dimensions to match the physical slide's dimensions. So then I enlarged the image, which made the cut images basically useless. And it made it a lot uglier. That brings us to the actual code. It's really underwhelming. I just had to make an input box for temperature, plug that into an equation for the slide position in millimeters, convert that to pixels, add the pixel value to the original y-coordinate of the tuning slide image, and change the y-coordinates based off of that. My only problem with this is that code.org doesn't take decimal pixel values, even though each pixel is more like 2 pixels. And depending on the screen size, it could be like 10 or 100 pixels. I'm not even sure if this part is on the rubric, but I thought I should at least give a demonstration or at least test my code. So I spent about half an hour trying to get a recording where my 2 hours of sleep wasn't visibly showing. Here is me playing a test note, which as you can see was fluctuating about 20 to 45 cents sharp. After using the app, that went to the range of 1 cent flat to 4 cents sharp. And after a few seconds, I actually managed to center my tone and got perfectly in tune. So this worked a lot better than I thought it would. That's nice. I made this thing because tuning takes too long, and I don't want to carry around an actual tuner everywhere I go. And also because I ran out of ideas. The idea was that if the temperature of my trombone increases, then the tuning will go sharp and I would need to pull out the tuning slide more because expanded metal and air would make the speed of sound faster. The independent variable in this scenario is the temperature, the dependent variable is how sharp the tuning goes. To create my project, I played 50 repeated view flats for an hour with the trombone at varying temperatures and recorded data on temperature, tuning accuracy, and millimeters that I pulled out the tuning slides to get back in tune. The data matched fairly well with my hypothesis. The tuning and temperature increased with each other like I expected them to. There are also some problems with my code because I didn't get any data on the F attachment. There isn't a reliable tuning note for the F attachment and I rarely use it, but it would be nice if I could tune that. There isn't really any other use for this unless I make a new interface for every instrument and collect enough data to calibrate those individually. But this probably wouldn't even work for string or percussion instruments. Do I have a closing transition? No.